Hey everyone, how are you all doing? Well, today we're going to discuss a very important chapter that is matrices. Let's begin. Let's have a quick look on what topics we're going to cover today. What are matrices? Order of matrix, types of matrices, trace of matrix, and equality of matrices. Need not worry, let's begin one by one. Now, what are matrices? Now, if you look at this halfway definition, I'm sure it will be very confusing. Let me make you understand. A matrix is an arrangement of elements in a rectangular form. Now, what are these elements? Well, these elements are numbers. Okay? So, the arrangement of these numbers in a rectangular form is known as a matrix. This is matrix A, let's say. Right? And this is matrix B. Why are we calling it a matrix? That is because it's an arrangement which is in the form of a rectangular array which comprises two things. Now here, a matrix, you must always remember it comprises two things. One is rows and the other is columns. Now, if you're wondering what rows and columns are, well, rows are horizontals. Now 2 and minus 9, they are row 1. 78 and 14, it is row 2. Are we getting? And then when we go on to matrix B, minus 6, 11, 8 is row 1. 56 minus 6 and 3 is row 2, and so on. That is called a row. Now when I talk about a column, the columns are verticals. Now here in matrix A, 2 and 78 form column 1. Minus 9 and 14 form column 2. Now when I talk about matrix B, here minus 6, 56 and minus 9 form column 1, and so on. So well, if you're going to define what a matrix is, it is an arrangement of elements, that is numbers, in a rectangular array comprising of rows and columns. As simple as that. Moving forward, we have order of matrix. Let's quickly learn. A matrix having m rows and n columns is said to be of the order m by n, which is also read as m cross n. Well, I hope we can get this by an example. Well, if you look over here, m rows and n columns. First of all, in matrix A, let's term this first matrix as matrix A. In matrix A, come on now, tell me how many rows and how many columns are there. Now, it's quite evident that there are 2 rows and 2 columns, isn't it? Now, when I talk about matrix B, here we have 3 rows and 3 columns. Now, what is the order of the matrix? The order of the matrix is m into n. That means 2 into 2. This is the order of this matrix. Now, if I talk about matrix B, it's going to be 3 into 3. That is how you'll define the order of a matrix. Let's say there are 2 rows. This is a question. Let's say there are 2 rows and there are 3 columns. Now, how will you write the order of the matrix? The order of the matrix will be rows times columns. That is 2 into 3. This will be your order of matrix. So here it is 2 into 2 and here it's 3 into 3. It doesn't mean you're going to call it like that. You're going to call it m by n. That is 2 by 2 or 2 cross 2. Here you're going to call it as 3 by 3 or 3 cross 3. Alright. So here the first number represents the rows and the second number represents the columns. The number of columns that are there in the matrix. Here again the first 3 represents the number of rows and the second 3 represents the number of columns. Moving forward, we have types of matrices. Let's begin. Now, firstly, we have square matrix. Now, this matrix comprises of the number of rows which is equal to the number of columns. That is, m will be equal to n. As discussed previously, m is the number of rows and n is the number of columns. A square matrix is such a matrix where the number of rows will be equal to the number of columns. Here we have a quick example. Well, here we have 2 rows and we have 2 columns. On the other hand, we have 3 rows and we have 3 columns. Now, what is the order of this matrix? 2 cross 2 and 3 cross 3. Well, here if you observe, m is definitely equal to n, isn't it? That is equal to here 2 and here it is equal to 3. That is, the number of rows will definitely be equal to the number of columns when we talk about the square matrix. Moving ahead, we have diagonal matrix. Here it says if each non-diagonal element of a square matrix is equal to 0, then the matrix is called diagonal matrix. I'm sure it's confusing. Let's have an example over here. Now, what is a non-diagonal element? Let's understand that first. Now, if I have 1, 2, 3, 4, 5, 6, 7, 8, 9. This is one matrix of the order 3 cross 3. Well, now what is a diagonal element and what is a non-diagonal element? Let's make sure we understand that first. Now, diagonal is always drawn from the left top to the right bottom. So this is the diagonal. Now, what are the diagonal elements? The diagonal elements are 1, 5 and 9. And what are the non-diagonal elements? The remaining numbers which does not comprise a diagonal. The circle ones are your non-diagonal elements. Alright. Now, if you have a look at this example which we have on the screen that says 45, 0, 0, minus 4. Here the diagonal is drawn in this manner, isn't it? So here, what are the diagonal elements? The diagonal elements are 45 and minus 4. 45 and minus 4 are the diagonal elements. Now, if I talk about the non-diagonal elements, the circled ones are the non-diagonal elements. Now, here, what is a diagonal matrix? If each non-diagonal element of a square matrix is equal to 0, that is, all the non-diagonal elements of a square matrix, if they are 0, then the matrix is called a diagonal matrix. That is, here we have 0, here we have 0. That means 0 and 0 here are nothing but the non-diagonal elements. On the other hand, if you look over here, again all the non-diagonal elements are equal to 0. That means such a matrix where the non-diagonal elements are 0 is known as a diagonal matrix. Moving ahead, we have a scalar matrix. If each non-diagonal element of a square matrix is 0 and all the diagonal elements are equal to each other, then it's called a scalar matrix. Well, I'm sure it's confusing. Let's have a quick example over here. Let's say 2, 3, 4, 5, 6, 7, 8, 9 and 10. Now I'm going to convert this into a scalar matrix. How do I do that? Here there are two conditions. One is all the non-diagonal elements must be equal to 0. And second is all the diagonal elements must be equal. Alright. Firstly, let me draw a diagonal. This is my diagonal. All the diagonal elements must be equal to 0. Either it can be 6, 6, 6, 2, 2, 2, 10, 10, 10. Let me make it 2, 2, 2. Alright. So this is 2, 2 and 2. So one condition is satisfied, that is all the diagonal elements must be equal. Secondly, all the non-diagonal elements must be equal to 0. That is, the numbers which do not comprise a diagonal, I'm going to mark them as 0. Now, such a matrix is known as a scalar matrix, where all the non-diagonal elements are 0 and all the diagonal elements are equal to each other. Here, what is the number that is common in that diagonal elements? 2. Alright. Here we have a quick example. Here we have 45, which is common. That is 45 and 45, they are equal. The diagonal elements are equal and the non-diagonal elements are equal to 0. So this is a scalar matrix. On the other hand, we have minus 9, which is the the diagonal element which is equal in all the cases, and the non-diagonal elements are equal to 0. So these two are an examples of scalar matrix. Now here comes a huge note. You might ask me, here I have a diagonal which is having 0. That means all the diagonal elements are 0. That means they are equal. All the diagonal elements are equal to 0. And all the non-diagonal elements are also 0. Now both the conditions are satisfied. Is it a scalar matrix? If this doubt arises in your mind, well, it is a scalar matrix. All the elements, if all the diagonal elements are equal to 0, that means here if all the diagonal elements are equal to 0, certainly they are equal, isn't it? 0 and 0, they are equal. So diagonal elements are equal. Also, the non-diagonal elements are 0. Such a matrix can also be called as scalar matrix. This is a huge note box. Moving ahead, we have unit matrix or identify matrix. Here it says, if each non-diagonal element of a square matrix is equal to 0, that is, all the non-diagonal elements which do not comprise a diagonal, if they are 0 and each diagonal element is equal to 1, all the diagonal elements, if they are equal to 1, then such a matrix is known as a unit matrix or a identify matrix. Now let's have another example. Let's say I have X, Y, Z, A, B, C, P, Q, R. I'm going to convert this into a unit matrix or an identify matrix. Now how do I do that? First of all, let me draw the diagonal. And I'm going to make all the diagonal elements equal to 1. That is the first, condition. And second condition is that all the other non-diagonal elements must be equal to 0. I'm erasing everything, every non-diagonal element, and equating that to 0. So such a matrix is known as a unit matrix. Moving forward, we have null matrix or zero matrix. If each element of the matrix is 0, then it's called a null matrix or zero matrix. It is as simple as that. The sentence makes it all. Even the word zero matrix says it all, that all the elements of a matrix, if they are 0, then it is known as a zero matrix. Now, if you see over here, what is the order of this matrix? 3 cross 3. Now, if I'm going to make an order of 2 cross 2, then the matrix is going to be in this way. 0, 0, 0, 0. This matrix is a zero matrix of the order 2 cross 2. Well, here we have that. Moving ahead, we have a row matrix. A row matrix is such a matrix which has only one row. As simple as that, here we have an example, 0, 1, 0. It has only one row. And again, we have 4, minus 4, and 6. This 2 has only one row. So all of these matrices are known as row matrices. Now let's have another example. 1, 2, 3. This is a row matrix. -5, -6, -2. This is a row matrix. Or -2, 2, 1. This is a row matrix. All the matrices which has only one row is known as a row matrix. Alright. Now before I move forward, I have a quick question for you. What is a column matrix? Now we knew that a row matrix is such a matrix which has only one row. Now what will a column matrix be? Well, you guessed that right. A column matrix is such a matrix which has only one column. Here we have 0, 1, 0. This is an example of a column matrix. Let's say I have 4, 5, 6. It's a column matrix. Let's say I have -2, 6, -4. This is a column matrix. So all of these are examples of column matrix. Here we have another example, 4, -4, 6. So all of these which contains only one column is known as a column matrix. Moving to the last matrix, we have triangular matrix. In triangular matrix, we have two types, that is upper triangular matrix and lower triangular matrix. If the triangle is getting formed towards the top of the matrix, here the triangle is getting formed towards the top of the matrix, such a matrix is known as the lower triangular matrix. Lower triangular matrix. On the other hand, if the triangle is getting formed at the bottom, then it is known as upper triangular matrix. Well, it simply means if it is towards the top, then it is lower triangular matrix. If it is towards the bottom, then it is upper triangular matrix. That comes us to the end of the topic, types of matrices. Moving forward, we have trace of matrix. Let's see. Well, the sum of the elements of the diagonal of a square matrix A is called the trace of A and is denoted by trace of A. Well, I'm sure it's confusing. Let us understand this. Here, this is the diagonal. Now it says the sum of the elements in this diagonal of this square matrix A. It is said to be matrix A, all right? Now the sum of the elements means nothing but the sum of the numbers. So -2 plus of -1 plus 5 is nothing but the trace of A. Trace of A. Alright. What is a trace of a matrix? Well, it is the sum of all the elements which are present in the diagonal. Alright. Now if I solve this, we have -2 -1 plus 5. Now this is nothing but -3 plus 5, which is 2. Now what is the trace of square matrix A? It is 2. Here we move to the last topic for today, that is equality of matrices. Now here it means matrices A and B are said to be equal if A and B are of the same order and the corresponding elements of A and B are the same. Well, all of these that you see on the screen over here seems to be quite confusing. Let's have a quick example. Here we have an example. Well, for checking the equality of matrices, remember just two conditions. I'm cut-shorting this definition into just 2 points. Well, you're going to take a look over these two conditions. That would suffice. One is the order of matrix must be equal. The order of matrix must be equal. On the other hand, every element also should be equal. Every element should be equal. In both the cases, 1 and 2 must be equal, alright? That is, order of matrix should be equal and every element should be equal. Now, if I have to form such a matrix where they are equal, or if I would say equality of matrices, right? Now, here we have two matrices. Let's name them as A and B. Now, order of matrix must be equal. So I'll make 1, 2, 3, 4, 5, 6, 7, 8, 9. X, Y, Z, A, B, C, P, Q, R. Now, have a look at this. The order of the matrix is equal 3 cross 3 and 3 cross 3, or 3 by 3 and 3 by 3. One condition is the satisfied. Now, if I talk about the second condition, every element must be equal. Now, the question arises in this manner. The examiner will give A and B matrices are equal. That means it satisfies the equality of matrices. Then what are X, Y, Z, A, B, C, P, Q, R? You're going to find out these variables. Well, you know that every element of the equality of matrices must be equal. Then X, Y, Z will be 1, 2, 3. Isn't it? A, B, C will be 4, 5, 6. And P, Q, R will be 7, 8, 9. That's it, right? So here, if you look over these two matrices on the screen, you will understand that it satisfies the two conditions. One is that the order of the matrix was equal, and second is that all the elements are equal to each other in the corresponding matrices, isn't it? So this is the equality of matrices. That drives us to the end of this video. Do not forget to like, share and subscribe. Thank you.